Yeah, yeah. Last talk of the day, right? So it'll be a good one. I'm pretty excited. I'm going to start out by giving you a little bit of my research background, so you have context into, why my co-founder and I started U.com. Talk a little bit about U.com itself, some of the things that we've been working on recently, some things that you'll see us announce more formally tomorrow, actually. So you can keep an eye out for blog posts and things like that. I'll have links and stuff at the end. So yeah, we'll start at somewhat almost the beginning for me. For me, NLP has always been about this quest for a single model, really. It's kind of funny. Today, I'm working on U.com with a guy named Richard Socher, our CEO, my co-founder, who I've been working with. I met him in 2013 when we were both students, as well as our director of engineering, Nathaniel Roth, here. And back in 2016, Nat and I actually did a class project for Richard's class. And it was all about this idea of a single model that could do everything. So I really didn't like the way visual question answering worked, classifying over different kinds of phrases and stuff like that, or sentiment analysis. I wanted everything to be generative and have it work a little bit more like language. And that's basically what initiated the conversation between me and Richard that got me into Salesforce research and did all of this research with him around trying to get there. So we did try for a bit. And my first paper ever, actually, was on something called contextualized word vectors back in 2017. And it's a fun fact that I actually don't know if I've really talked about much. But this paper happened because I couldn't do the multitasking stuff. I tried to work on it for like 6 months, something like that. And all I could actually prove at the time was that if you took a model and pre-trained it on something, on one task, you could take it and use it for other tasks. This was kind of novel still at the time, but I had this approach, that was this generative approach that I just couldn't get working for translation, summarization. A lot of data sets that we have now didn't exist. So it was pretty funny when this paper came out and the NLP community got really into contextualized word vectors for a while. And I kind of moved directly back to that multitask learning problem with Richard and some of my other collaborators at Salesforce, Nitish and Sai Ming. And this time around, it was like another year, we actually built a generative approach that took in 10 tasks and kind of sampled them from all over NLP. So it was, machine translation and question answering, things like squad, sentiment classification, even things like text to SQL. Tried to just fit it all into one benchmark. That way I could have a generative approach and just describe what the tasks were in natural language. On this paper and over that time, we learned so much about a lot of the things that are still happening today, so many things that didn't even make it in the paper. Like all these questions, now I go back and look at these pictures from back then, it's like all these questions, one of the things we noticed was tiny wording changes and stuff like that could change performance. And we saw these early precursors of things like prompt engineering and distracting tasks that hurt performance, or the model couldn't do common sense reasoning, but it could kind of memorize things, but maybe that hurt machine translation performance. And we had to deal with all of these things that were happening at the time. And although my first paper went over pretty well with contextualized word vectors, this paper was like an absolute reject. I got a lot of flack in my peer reviews for this being perhaps a paper that does more harm than good. And it was totally misguided. So they were very certain, and that hurt a little bit, but we kept going, more or less. I was very happy when I'd been talking with some folks at other labs, and OpenAI came out like 6 or 7 months later with GPT-2, pushing this idea further of like a single model, and we started seeing language modeling work for this stuff. So that was super exciting, and basically we just took off from there. So in like 2019, 2020, some of the things we first started thinking about was like how to control generation more. Something that is still a big problem for normal users, especially. At U.com, we see a lot of consumers that aren't as familiar with all of these things. So you have to bridge the gap between, behavior that they're used to doing and actually extracting a lot of value that might already exist in the technology. So kind of getting that product fit in between and helping people get there is still something that I relate back to some of our early work on control. We did some protein language modeling, which was really interesting. It's still one of the most promising areas, I think, right now for all of this technology to yield like a lot of fruit, because in that case, back then when we were doing all of these things, it was like, oh, is the model memorizing, or is it generalizing? Is it just copying from all over the web? What's going on? Proteins doesn't matter, right? It's like, if this thing works, it works. We don't really care if it's combining different subsequences from other sequences it's already seen. So there's been some great stuff on that. Factual consistency, we were already starting to see was a major issue, something I'm going to talk about that U.com faces today still. A lot of people talk about hallucination, and this is something that we were seeing in all of these generative models. And then we actually had a paper on using a single language model for all of dialogue. In this case, it was task-oriented dialogue, and as you can imagine, U.com being in AI and search, being in that space for the last 3 years, dialogue or chat, has really changed things. So in 2020, a lot of the NLP community was more on board with this idea of language models, transfer learning, multitask learning, single model approaches. So Richard and I were both looking for ways to have the most impact again. And the way that I kind of assess impact for me has always been, I have a strong intuition, like a gut feeling, and a lot of people think I'm wrong, because that means if I don't do it, then, well, maybe no one else would, right? So in 2020, we were seeing this inflection point happening with the technology, and we saw that maybe search would be an area ripe for disruption. If you had models that could really understand people better, maybe you could do all sorts of things different. You could make a different kind of index. You could do search differently entirely. So we really wanted to get out in the wild and pursue kind of restructuring the gateway to the internet in that sense, along with the incentive models around it. So yeah, it seemed pretty ripe for it because there'd been maybe 20 years of mostly the same thing, page of links, and mostly just that. So our whole vision for U.com when we started out was to aim to be more of a do engine rather than a search engine. And that's what we were really hoping these technologies that we had been trying to make for a while could help us do. And so that's when Nat actually jumped back in to the frame, and we all started working together in late 2020. And so much of U.com has been about this idea of taking every search result on the page, every one of those blue links, and trying to go one layer deeper in terms of the user's intent, doing something for them, providing something for them. So in 2021, we were just experimenting with different kinds of result layouts, pulling in more information from the page, providing code snippets, allowing developers to copy and paste things. And so developers started to really like us. We released something called UWrite, which was a language model that would generate essays and social media posts and stuff like that in early 2022, because we started seeing, if people were searching for things like code or how to write an essay or whatever it was, you could just provide them an application that could do that for them. And so we really encountered this kind of interesting problem where people had these expectations about what search was, and then all of a sudden you were trying to change that expectation with some technology, and it was pretty interesting to watch how people could see an AI image generation app come up when they're searching for AI art, because we're like, if you're searching for AI art, you're interested in that, why don't you just participate directly, create it right here? But some people, are like, whoa, what is this? They don't know anything about AI, maybe, and so it was very interesting to watch behavior change over this time, especially when LLMs entered their chat phase. When ChatGPT showed everybody that a conversational interface might finally be ready to tackle more complex queries. Now, since then, U.com has been really focused on basically 3 shortcomings with the LLMs, trying to layer this conversational interface on top of the search engine that we'd built underneath. We'd spend a lot of time getting simple basics right, like what's the weather, like showing a nice plot. What's this? What are the stocks for this and that? People like to have a lot of basics in a search engine. Now with this new technology, what do you do with it if it can't stay up to date? It can't really provide accurate citations. Hallucinates a lot of answers, even to things that we basically solved, like presenting stock prices. And then it couldn't reason about a lot of things either, where people would just go and find that information instead. So it triggered that, that feeling of, well, how do we make search results more actionable in these ways? And for the first one, we just dropped chat directly into our search results page and started allowing people to ask follow-up questions about the search results, allowing the LLM to generate things. And this started to solve the problems around citations, for example, and staying up to date. This basically, in a form of retrieval augmented generation here, where you're retrieving over all of the internet, you can suddenly know exactly what's happening all the time without needing to continually train your model. You really just need the reasoning capabilities of the model and be able to kind of balance what the model knows with this incoming information. So we started connecting it to a whole bunch of APIs and our own search index. And you can see, before a language model would have said it doesn't know about certain things. And after, it provides a very detailed response. It can cite sources and really increase the kind of level of trust that users could have in these kind of results. The second one, for hallucination, we actually found that while adding search results and adding things like retrieval augmented generation over text and that modality helped, sometimes it just made sense to still show those kinds of plots. So in this example, we were allowing people to have a conversation, maybe ask a question like, what is CRM? Salesforce background, so CRM. And what's going on with them? What's the biggest company? What's their stock price? This is a sequence of queries that would have been really hard to do before the conversational interface was on top of a search engine. Once you tie them together, you can get this really nice effect where you can provide information, maybe that the language model already knows, or it needs to pull in from the internet, and then it can also pull in other APIs and start using these tools when maybe it doesn't know exactly what's going on, but it knows where to look and how to find it. And then you can keep going with your conversation. So that's how we started handling that one, and it's still ongoing. We're still connecting more and more things into U.com, and I'll get to some of those at the end as well. But this third one was pretty interesting. So this is what we're going to launch tomorrow. So this is one you can check out all our benchmarks and all our evaluations. And this is going to be our version of an agent. So up until this point, U.com has been able to do things like write code. And when I'm talking about an agent, I really mean allowing the AI behind U.com to really execute code, take actions on it, kind of decide what to do next, maybe loop over things and have like a lot more complex behavior. And we found that this is really good for answering complex STEM questions, GRE, some of the other benchmarks out there on like ACT, practice tests, and stuff like that. So I really like this. So I'm just going to show you a couple examples of these in particular. So asking about a monthly mortgage payment, and if you borrow this much, like you can actually get the code, and then we run it. It's Python code, right? So the kind of potential here, as we're adding more and more libraries, is that the behavior can get more and more complex and hopefully more useful for people. And things will, get checked. You can see the output. You can take averages. You can do all of the kind of things you want to do with some of the basic mathematical, like Python libraries. I like this one too because it's a good example of the model actually writing code, hitting an error, and then deciding, okay, I got an error, I can't use that library, so I'm actually going to go figure out a different way to do it, and writing like a different set of code, and then getting the right answer, which is just something that I don't know, like a search engine doing that, I think a few years ago, a lot of people would have never guessed. I don't think we would have even really known that we would be there, be able to do that. So this idea of a search engine has really been changing and shape-shifting, along with concepts around chat and assistance and things like that. And then I'm going to give a bonus one too. Another one we've been working on recently is just the fact that these language models don't know you. So for this one, put a little video here as well. And I write that I have a truck, and I want to know, if it's safe for kids. And at first, I get a pretty generic answer from a language model. It's still citing the search results, but this has really nothing to do with me. I can tell it a little bit more about myself, like I like painting, I like writing. I'm taking a tap dancing class, which is true. It's great. You should also do that. And I can tell it my name. And then the model can actually use this information, right? So if you're giving it this information about you, it can actually personalize search results for you. And we're in SF right now, so if I wanted to know what was going on this weekend, I can ask it. And it actually knows who I am. It knows I like art. It can give me suggestions about that. It knows I want to do maybe some dancing. And in this way, we're going to start layering in more and more levels of understanding who you are, which is really just another form of context, going all the way back to contextualized word vectors at the beginning and trying to provide these different contexts for models. So much of U.com is about tapping into these additional contexts so that we can actually do more for you and understand what you want. So I want to leave some time for questions and everything too. So in the future, there are three things, I guess, specifically on this slide that I'd love to engage with people on. One is this single model hypothesis, which I think is especially relevant right now because we're in a time where we may or may not be seeing some of the diminishing returns on some of the language model training. I'm sure there's a lot more that's going to happen, but a few years ago, around the GPT-2 time, it also was the case that people started adding in things like vector-based retrieval into language models. And in some sense, it operated as this mechanism to allow the language model to do more without actually incorporating that into the single model, right? You're kind of bolting something on. And at U.com, we built a lot of technology around these kind of things, like our own search index, our own retrieval augmented generation, and LLM and model coordination layer, our agent, all of things which also in keeping kind of with my research time, I would like to make available to other people, kind of empower people to develop on top of those things. So if you're interested in the single model approach, if you have thoughts there, even things like training on English to help protein language models, which is something we tried and kind of worked. It learned faster. It's why? I don't know. People are saying code that helps, training on code can help with reasoning. I still think there's a lot to be done on exploring what happens if we just stop thinking about tasks and start thinking about models that just take in information and output information across modalities, just kind of get rid of these concepts that we've invented to make problems more tractable, but that we don't always need. If you're interested in maybe testing out APIs, like testing out U.com in your own stuff, the same technology that's powering the site itself, if those would be useful for you, please reach out to me too. And then if you're interested in any of this stuff that's actually in U.com and building into the site itself, like the agent, we're really looking to expand its capabilities. So definitely check out all of our hiring pages and everything. With that, I will stop and give us time for questions and conversation if people want to chat. Any thoughts? Questions? Ooh, we got one.
Taking actions by generating code and then executing the code. I mean, those examples were very impressive. Are there any details you can share about, I imagine it was hard to get working. Is there anything you can share about how well it works or where it fails or tricks for getting it to work well? Yeah, for sure. So the first thing to kind of get it working in this scenario was, well, there was one main decision, which I think is worth talking about, which is, focusing on getting it to use something like Python instead of, integrating with some sort of, another API and like outsourcing computation. So I think that, I like that as a first step. It actually surmounted a lot of issues around, getting a language model to maybe understand maybe like a computational language or a programming language that it's less familiar with. One of the things that you have to keep in mind, all the data going into these things is part of the craft is having intuition about like which data it might have a lot of compared to another one. So if you're thinking in terms of just like low resource versus high resource languages, that would be one. So for the high level decision, go with Python. It's like there's a lot of Python out there. It also enables you to do a lot of things. And that immediately solved and improved on some of the benchmarks that we were using. Benchmark-wise, you will see, if you check out the blog post tomorrow, then there's going to be a big table on ACT practice tests, the MMLU benchmarks, GRE tests, like stuff like that. It does a lot better, like in some cases maybe 20% absolute improvement over like a GPT-4. So adding in this kind of functionality definitely makes a huge difference on things like this. And most things out there don't have that. So I think you should definitely check out the blog post with all the comparisons. We have a bunch of like side-by-side examples for like other non-U.com stuff as well. And then let me think of some other tips. One of the big ones, I really like that example where it actually encountered an error. And I think getting it to, a lot of people like talk about getting the models to debug code on their own. So like having a background process that can actually do that and refining that is definitely worth it as well. Because you don't want it to get stuck and just be done. You want it to continually like try different approaches. So that is well worth it for some of the performance gains too. There'll be more insights in the blog as well. It makes sense. Just curious, how far are you taking the actions? Like, are you letting it send emails on my behalf, or just? I mean, you can do a lot with Python code.
Yeah. So right now, it's fairly constrained. It's constrained to those like mathematical libraries or like scientific libraries. So no emails on your behalf. It's also sandbox an environment where it wouldn't be able to do that. Where would we want to? I don't know. Anything that you're comfortable with, I guess, which I think might increase over time. There's going to be a lot of generative technology that comes into basically every product it seems we're interacting with on the internet. So I think people will get more familiar with those things. And over time, U Agent is going to try to push those boundaries a little bit and do things that maybe makes you wonder whether you want it to do that. And that's okay. It doesn't have to do it. You just don't ask it to do that, I guess, and it won't.
Just following up on the action, you mentioned you want to be a do engine. Mm-hmm. I guess unlike the NLP side where there's like tons of text on the web, like if you want to do something, you want to observe users doing it.
Yep.
And probably have an associated language, like, oh, I'm now sending an email, and this is like, I'm clicking this. But fundamentally, how do you can't even get such a data. Just see people doing stuff.
Yeah, that's a great question. Yeah, like actually watching people do some of the things on the web that you'd want to be able to imitate. I mean, that would be fantastic if you could just get to, you know, an amazing data set of sequences of actions, and you just trained the same kind of model, but over sequences of actions instead. There are, like, I think there are ways to do that to some extent, like if you own a browser, or if you own some kind of distribution platform, or some place where you can actually access that data. I think, and so that's kind of the obvious approach. I think the less obvious, unconfirmed approach would be to say, okay, well, what if I don't have access to all that? I mean, in the past, we have seen, to some extent, how language describing things can be a lot more powerful than you would think, you know? So, I mean, yeah, it's an open question on whether a language can really represent how much it can represent, but if, maybe going back to the first question a little bit, like you could be very clever about tapping into like a language distribution that is also focused on those kinds of things, I think that'd be a valuable data set, at least to supplement, and then also to kind of piggyback on everything we know about language and how to work with language. Yeah, but it is a big challenge.
Really cool stuff. Just a quick question. You went through a bunch of use cases. What are the things that you're finding people do most commonly? And have you been surprised about what people are either doing or not doing?
Yeah, good question. So U.com wise, we definitely have a lot of developers and students and people who are also of younger demographics, or people who are looking for tools to solve some like immediate problems. I think what's especially interesting about that is often the way that they ask for it is very different than before we had the conversational interface. So even like old models that, you know, were used to understand intent and understand what a user wants, it's just like they needed to be redone, basically, you know, because users are coming in with more open minds in some sense, and that's creating like a lot of different behavior. We also see, I think, a lot of people that see a lot of like consumer behavior, see people experimenting a ton. So I think very regularly we'll see people doing things that are working, and we didn't know that it was going to work, you know, or it was going to do that. But yeah, specifically for us, a lot of students and a lot of developers right now, they're getting a lot of the value out of just like something that knows a lot about what's happened in the world and is happening in the world, and so can provide these like nice, concise summaries or study guides and kind of work with them in whatever they're trying to do.
All right, so all of this is good. I have a question on the engineering side. So
Cool.
Regarding on the RAG, I'm assuming you guys started before we have Llama Index, Landsmiths, and all of that. So
Yeah.
Can you talk about on that side, like what do you use? And
Yeah. So we use a lot of things. We're pretty pragmatic in our approach. So we have our own crawling system, for example, since we want to understand the web and we want to be able to provide that information to the language model. And one of the key things that we've been seeing is a big differentiator for the responses and the response quality is actually indexing the web in slightly different ways, focusing on kind of, if you imagine building an index for LLMs and for developers using LLMs, rather than, you know, again, going back to like a list of blue links with maybe some descriptions that sometimes give you the answer, but are kind of on average mostly designed to get someone to click on those links, providing like a deeper view on the content we have access to and giving that to an LLM goes a long way. So on that very base layer, just indexing the web both in traditional ways, like an inverted index, and also with vector databases, being a little bit more choosy and selective about what you're indexing has been, like, right now, yielding a lot of benefits for us. We've played around with everything out there, though. Essentially, we've used Pinecone, we've used VBA for things, we've tried pretty much everything, and we have kind of our own internal suite of benchmarks and everything as well. That's a combination of academic benchmarks, but also benchmarks we've developed over the years, going back to even some of those basics like weather, like making sure those things always work and we can keep advancing forward. So benchmark-wise, kind of tech stack-wise, we also have like a collection of language models that we use, which is maybe relevant to your question as well. And selecting which one to use for different kinds of intents or different kinds of user behavior has been really important, especially since some LLMs might be better for creative writing and creative writing intents, and others you might want not only fine-tuned but maybe even prompted and have the whole stack optimized for like citing things and like basically getting that language model to never deviate from the data that it's given. Maybe if you're trying to answer questions about stocks or the recent news, things like that. So having like a collection and almost like a bag of LLMs that you can go to for different use cases has also paid a lot of dividends. And we use as much as we can there. Yeah, and fine-tuning whatever possible. Like if you find a concrete task, we do a lot of fine-tuning. Yeah, happy to talk about any other more specific pieces too, if you want to go into some.
Cool. Well, thank you. I think we're just about at time. So thank you,
All right.
Bryan.
Thanks.